A warm welcome to you. Thank you for viewing the video. Welcome back. So in the last video we have seen how to define the slope. We have gone through this. We have taken a simple example and understood how the slope varies. We define that slope equal to difference in the y coordinates divided by difference in the x coordinates of a 2 points. That's nothing but which we generally denote by m. M equal to slope equal to y2 minus y1 by x2 minus x1. In this particular video, our focus will be to find out the relation between the slopes of parallel lines and perpendicular lines. To do that, I have taken a simple example. If you see here, I have the coordinates a, b, c, d, and by looking at that picture, you can say that that's a square. So let me try to join the points of the square. This is my square, and I also want to have the diagonals joined, so I'll join the diagonals. Let's say this point is equal to O. So the idea of taking this example is, you are familiar with the square and you know that the properties of square is opposite sides are parallel and equal, and also the consecutive sides are perpendicular to each other, because square makes 90 degrees at all sides. And also you are aware that the diagonals bisect each other at 90 degrees angles. So the idea is to find out the slopes of the sides of the square and the diagonals of the squares, and thereby look at the relationship what we can arrive between parallel lines and perpendicular lines. Once we are done with this, we'll see also diametrically using trigonometry how we can find out the relationship between the slopes in case of parallel lines and perpendicular lines. So let's go ahead and let's find out the slopes of all the sides. So the slope of AB, I will say m of AB is equal to y2 minus y1, that's nothing but 6 minus 6 divided by 6 minus 2, that is 0. Slope of BC, MBC, is nothing but y coordinate of C and B, 2 minus 6, 2 minus 6, and x coordinates for B and C is 6. So this is undefined. Similarly, let me do for CD. CD, you see that y coordinate is 2, 2 minus 2 divided by, and your x coordinates are 6 and 2. This is 0. We'll also do for, we have done for AB, BC, CD. Let's do for DA. MDA is equal to A y coordinate is 6, dy coordinate is 2. So it's 6 minus 2 divided by 2 minus 2, which is again undefined. At the end, let's look at the diagonals. Let's find out for MAC and BD. AC 2 minus 6, that's minus 4, divided by 6 minus 2, that's 4. This is nothing but minus 1. For BD, D minus B y coordinate, D y coordinate is 2 and B y coordinate is 6. So it will be 2 minus 6 divided by x coordinate of D minus B, that's 2 minus 6 again. This is nothing but equal to 1. So MAC is equal to 1 and MBD is equal to, MAC is negative of 1 and MBD is equal to 1. So we have seen that AB slope is 0. This we already know because it's a horizontal line. Similarly, we know BC slope is undefined, which tells me that it's parallel to the y-axis, and I know AB is parallel to the x-axis. That means these two lines are perpendicular to each other. Now let's take the case of AB and CD. You can see slope of AB is 0 and also slope of CD is 0, which gives an interesting conclusion that slope of parallel lines are equal. Now what else we can arrive? Let's look at the diagonals. If I look at the diagonal, we know here we are climbing up, the slope is positive, that's 1. Whereas you look at the other diagonal, AC, where we are climbing down, the slope is negative. And surprisingly, these two are equal in magnitude, but with a opposite sign. So this gives me a relationship for case of parallel lines. MAB is equal to MCD, that's parallel lines or slopes are equal, and in case of perpendicular lines, that is MAC into MBD, that means both the perpendicular line slopes equate to -1. These are the two relationships we are able to identify with the help of this diagram. Let me just repeat this before I clear and move to the next screen. I have plotted the square ABCD. I have found the slope of all the sides AB, BC, CD, DA and also diagonals AC and BD. We have seen that the parallel lines have the same slope AB, CD, AD, BC respectively, and also we have seen that the diagonals slopes are equal in magnitude but opposite in sign, which gives an important relationship that in case of perpendicular lines, the slopes are slope of, suppose let us say M1, M2, we can say M1, M2, two lines which are perpendicular. I can say M1, M2 equal to -1, or also I can say that M1 equal to minus of 1 by M2, which is nothing but saying that slope of one perpendicular line is nothing but inverse reciprocal, negative reciprocal of other slope. So let's move ahead. We have established the relationship between the parallel lines and perpendicular line slopes. Now let's look at from the geometry perspective using trigonometry and see like how we can find out the same relationship. Okay. Now let's take two parallel lines. Now before moving ahead, we have seen that M is equal to y2 minus y1 by x2 minus x1, nothing but this is the straight line. This is point x1 comma y1. This is point x2 comma y2. Let's say this line is AB. We know that y2 minus y1, which is nothing but this distance, divided by x2 minus x1, that's nothing but this distance, or simply difference of y coordinates divided by difference of x coordinates gives me the slope. And if you know trigonometry, you can also call it as tangent of the angle, nothing but tan theta. So suppose I have two lines and I want to establish the relationship between them. I can take them as m1 comma m2 and I can prove tan theta 1 is equal to tan theta 2 in case of parallel lines. And similarly, m1 m2 is equal to minus of 1 or tan theta 1 into tan theta 2 equal to minus 1 in case of perpendicular lines. So let's go ahead and see how we can do this. Let me say that I have two parallel lines. These are my two parallel lines, and so we know, suppose, let us say that, just give me a minute, I'll just erase this so that you can see it clearly. Let's say that this is my coordinate axis. There are two lines parallel to each other. So this is one line and this is another line. There are two lines which are parallel to each other. Now the definition of the slope in trigonometry, where we specify with respect to the theta, theta is nothing but the angle made by the line with the positive direction of the x-axis in anti-clockwise direction. Let me repeat that again, this is important. Theta is the angle made by the line in the direction of positive x-axis direction in anti-clockwise direction. So that is nothing but this way, anti-clockwise direction along the positive x-axis. Suppose I say theta 1. Let us say that there is another parallel line which is making an angle of theta 2. Now we want to prove, in case of parallel lines, that tan theta 1 equal to tan theta 2 or theta 1 equal to theta 2. Now you can see that these two are parallel lines and your x-axis is a transversal. You can clearly see that theta 1 is equal to theta 2 because they are the corresponding angles, which proves that tan theta 1 equal to tan theta 2. That's nothing but, in case of parallel lines, m1 is equal to m2. How we did that? We equated theta 1 to theta 2, theta 1 equal to theta 2. That gave me tan theta 1 equal to tan theta 2. How we are able to say theta 1 equal to theta 2? Because those two parallel lines are intersected by the x-axis. Now here x-axis acts as a transversal, and you know that if two parallel lines are intersected by a transversal, the corresponding angles are equal. We have learned that. So theta 1 is equal to theta 2, tan theta 1 equal to tan theta 2, which gives me m1 equal to m2, which we have proved earlier with an example by taking a square. Now let's look at the other case. The other case is, we want to prove that in case of perpendicular lines, the slopes are inverse reciprocal of negative reciprocal of others, or m1 into m2 equal to minus 1 if m1 m2 are the slopes of the two lines. Now for this, let me again draw the coordinate axis. Let me say that this is my x-axis and this is my y-axis. Okay, now I have a straight line. So let me take a straight line. This is my straight line. And there is another straight line which is perpendicular to this straight line. Let me say this is my straight line which is perpendicular to this straight line. We know that this angle is 90 degrees. And we also know by the definition of the angle that this is the line L1 and this is the line L2. L1 makes an angle, suppose let us say L1 makes an angle theta 1 with the positive direction of x-axis in anti-clockwise direction. This angle is theta 1. Similarly, L2 makes with the positive direction of x-axis the angle theta 2. Now, if you look at the triangle, just give me a minute, I will erase that to make it more clear. This is 90 degrees, this is your hypotenuse, this is 90 degrees, this is theta 1 and this whole is theta 2. You can see that in this triangle, theta 2 is the exterior angle of this side, which is nothing but equivalent to, as per the properties of triangles, theta 2 is equal to 90 plus theta 1. So, if I apply tangent on theta 2 and theta 1, I will get tan theta 2 equal to tan 90 plus theta 1, which is nothing but equal to minus of cot theta 1, which gives me the relationship that tan theta 1 into tan theta 2 equal to minus 1. That's nothing but m1 m2 equal to minus 1. So we have seen that, but if you think we are not clear, let me just do that again here. See here, theta 2 is equal to 90 plus theta 1. Now I can apply tan on both sides. This becomes tan theta 2. Tan of 90 plus theta 1. In the second quadrant, tan is negative. And if you add 90 to tan, it will become cot. So this becomes minus of cot theta 1. And you know cot theta 1 is nothing but equal to minus of 1 by tan theta 1. These are fundamentals of trigonometry. So we know tan theta 1 tan theta 2 equal to minus 1. That's nothing but m1 into m2 equal to minus 1. So in this video we have taken an example to arrive at the relationship between the parallel lines and perpendicular lines, and also we have proved the same by leveraging trigonometry also. So now we know that whatever we have learned earlier, slope equal to y2 minus y1 by x2 minus x1 is also equal to tan theta. So now you can see the relation between the trigonometry and the coordinate geometry, and in future classes you can see that this is also equal to dy by dx, nothing but you have a link to the calculus. See how interesting it is. Okay, we'll stop here. In the next class we will find or frame the equations for different scenarios, straight lines. We'll derive the equation for the lines parallel to the x-axis, parallel to the y-axis. We will also find out or form equations for different scenarios when you have been given 2 points, you have been given 1 point and a slope of a line, or you have been given intercepts of a line. We'll go through all the varieties. It's going to be more interested. Thanks for joining. See you in the next video. Thanks for now. Bye bye.